Customatory. So, hello everyone. Welcome to our webinar session. So, I'm so overwhelmed to welcome you all to our webinar session on the topic Basics of Internet of Things. So, now it's time to invite the kingpin of the event, our speaker, Mr. Ashwin Shaji. He's a final year CSE student, ECE student of Amal Jyoti College of Engineering. So I'm so excited to host the event. I hope it's time for Ashwin to handle the session.
Hello.
Is
Good
it
evening,
audible,
everyone.
Ashwin?
Yeah. Hi. Hi, everyone.
Okay.
So, good evening, everyone. Hope everyone is doing fine. I'm Ashwin Shaji. I'm a final year EC student from Middleware College of Engineering in Kottayam. So I was the former chair of IEEE PES SB, and yeah. So let me tell you something about my, what will you say, my journey with IoT. Okay, so how do I started my how I started my IoT journey was like um, during my third year starting during the start of the third year I started doing projects on IoT. Before that, in first year, I heard about IoT somewhere in some course, but after that there wasn't that much. I didn't do anything research. I didn't do any research on IoT and all. So after that, during the S4 semester breaks in that June July period, I came across a cloud IoT cloud IoT platform called Bolt. So at that time, they were conducting a student ambassador program. So basically, they were promoting their product, and we have to promote their product through digital marketing and all. So I started doing that as a student ambassador for them because during that time I don't know what to do, and I hadn't thought about what should I do in the future. So I just started doing that ambassador thing, and after all that ambassador stuff, by the end of by the mid of July, I think they gave me an offer, a discount, like buy their product at some discounted rates. So okay, I thought that this is going to be new tech, I should learn it. So it's already like my third year was going to start. So I bought that product. The product consists of a course on basics of IoT and machine learning. That was a basic stuff, and some hardware components, basically electronic products. It consists of a Wi-Fi module, microcontroller, and some electronic components. So yeah, that's how I started the course. I started doing the course and started doing the projects that were given by them. So step by step, I started doing the projects in IoT. That's how my IoT journey starts. So yeah, after that, the third year, I did a project in IoT itself, the third year project, and now I am currently also doing my final year project in IoT also. So IoT is a very interesting tech because nowadays everything is connected through internet. So IoT is everywhere. So let's start the webinar. Okay, so let me tell you what's IoT. By definition, if you're going what is an IoT, then it's something like this. The Internet of Things is a system of interrelated computing devices that can be mechanical and digital machines, objects, animal, or people that are provided with unique ID or identifier. Okay, so and the ability to transfer data over a network without requiring human to human or human to computer interaction. So this is the ideal definition for IoT. Okay, by the mean, what did I mean by ideal is that even today, not all the IoT products or the projects are completely avoiding human interaction. We can't. At some point, we need human interaction. So we can't tell that till the point we have done that we haven't avoided the human interaction. So there will be some points where the human interaction is needed. For example, take a cattle farm. Okay, so in a cattle farm, if we implemented an IoT, what will we do for IoT is that uh, when a cattle or when a cow, we first of all we give the cow some unique ID using an RFID. So RFID basically does is that it gives a unique ID to each thing. Okay, so here the thing is cow. So the RFID gives the cow a specific identification number. Using that, after that, what we will do that we will create a virtual boundary around the cattle farm. So we can know where and when and where they are present, the cows. So we can pinpoint their location. If the cows leave that boundary, then it will alert the in charge, the person that is in charge of the cattle farm. So we see that there is a human interaction required in this. So similarly, if we are taking an home automation project or which is done over an internet, so what sometimes the connections fail. Okay, sometimes the internet goes down, and sometimes what can we say, sometimes there may be some wire loose connections. So at that point of time, humans need to interact with the machines directly. That's what the human to human or human to computer interaction mean here. Okay, so there will always come a human interaction. We can't fully avoid, okay, human interaction till now. Okay, so now let's go ahead. Let's see the life cycle of an Internet of Things. Okay, the life cycle, it's basically divided into 4 parts. It's collect means collecting the data from the environment where the devices are present. Then what we will do is we will communicate. Then comes the communication stage. During this stage, the device actually communicate with the server. Okay, so the data will be sent to the server. Okay, that basically what communicate means here. After that comes the analysis. The analysis is done in the server. The server, in the server, we will define some protocols and we will define some commands that if this happens, then what should be the output. So according to that, according to the data that has been collected from the devices, the server will analyze and give us an output. Okay, then the final stage, the act stage. During that act stage, what happens is that the output from the server, that what should the device do now. If for an example, take the home automation. If the home automation is like defined as here, when the sun goes down, the lights in the house will be turned on. So what we will do here is that we will collect the sensor data from a photoresistor. We are using a photoresistor for to see that if the sun or the light outside the home or outside the house has been dimmed or not, or is the light sufficient. So we will use a photoresistor. So when we use a photoresistor, we can know the outside luminosity. So like that, when the resistor value drops down below a certain value, the server, what will be the server do is that the server will give an output to turn on the light. So taking that command and using that command, the microcontroller or the brain, what we say here is the brain of the system. The microcontroller does that. When the output from the server comes like turn on the device, then the microcontroller turns on the bulb, lights, fans, whatever thing is. Okay, so that's basically the 4 stages of the life stages of Internet of Things. First is the collect, then comes the communicate, then analyze and act. Now, IoT architecture, it's similar to the life cycle or the stages. Okay, IoT architecture is also basically divided into 4 parts. First is the smart things. Second is the networks. Third is the middleware, and fourth is the application. I will go detail. I will go into the details of these things. So let's go to the next slide. So, what should an IoT architecture actually do? So, what we can say is that here, IoT architecture should be capable of doing 4 things. First is the connectivity of devices. That what all the from the connectivity of devices, I mean the sensors and the output devices. The input and the output devices should be connected to the internet so that they can exchange data accordingly. Then comes the data collection or the ingestion part. During the data collection, the architecture should ingest or should collect the data from the sensors. Okay, like I said during the home automation project, what the photoregister actually sends the data to the server. So the server should actually collect the data. It shouldn't reject the data from the sensor. Then come the data processing. So data processing here means analyzing of the data. Like is the value, like take the same example of home automation. Is the value of the photoresistors below a certain value, then you should do this. If not, then what? Like that. That's the data processing step. Then comes the data storage. That the data that the value, digital value or the digital data that has been sent by the sensor or the thing to the server should actually be stored for some time, at least for some times. So so that we can do some analysis, more analysis using some machine learning algorithm or big data, like that. Okay, so an IoT architecture should be capable of doing all these 4 things very quickly while still producing a real-time data. What this line actually means is that the IoT architecture should do all the 4 things that has been mentioned above while doing the real-time data collection. It should always collect the data from the sensors while doing these 4 things. The data collection shouldn't be affected by these 4 things. That's what actually it's meant here. Okay, so yeah, basically this is what an IoT architecture should do. So whenever we design an architecture for IoT, you have to keep these 4 things in mind. Okay, you can't avoid any of these things. Now, I will dive deep into the architecture. First comes the smart things. Smart things basically are the devices that are used for data collection and actuation. Smart things can be anything. Okay, I told you sensors. Sensors are smart things. When we embed those sensors with a microcontroller, they actually become smart. Okay, so likewise, for actuation, it can be anything. It can be at home. It can be a light, a fan, an AC, a fridge, anything. Okay, like by actuation, what it means is giving an electrical signal and doing some mechanical operation or things like that. So giving an electrical signal will do a mechanical operation. That's what means. What it's meant by actuation. So for actuation at the home, it can be light, fan, as I mentioned. It can be your car also. At office also, it can be some in the office. It can be your PC. It can be turned on when you come to the office. What will we say? Office in the office main doors and all. So it can in the office. It can be your PC. It can be lights, fan, AC. Yeah. Then in manufacturing plants, actually, what is it means that in manufacturing plant there are many machines. So we have to control those machines and we have to give an appropriate output also. So for controlling, we have to embed some sensors in the machine manufacturing plants, and accordingly we have to send an output to those machines, and those machines will be the smart things that will actuate that will actuate accordingly to the commands that are given by us. Okay, so there can be three things. The three things are sensors, actuators, and trackers. So these three things are actually smart things. So by sensors, I mean it can be a temperature sensor, a pressure sensor, a chemical sensor, or a MEMS based sensor. So yeah, so what happening is here, like we sense a particular, take a medicine manufacturing plant. Okay, medicines are like very delicate things. If a certain temperature or pressure is being crossed during a certain manufacturing of the product, at certain stage of the manufacturing, then the whole batch of the medicine will get cancelled. It can't be sold. So what we will do here is that we will embed the pressure and temperature sensor at the manufacturing plant, and it will monitor the temperature and pressure. If the temperature rises or drops below a certain value, it will notify the the person in charge in that manufacturing plant. So by doing this, we can actually save those things, save that manufacturing plant from having a huge loss. How it is done? Like if for example, if the medicine manufacturing is done at 30 degree and it can't get below 25 degrees. So when the temperature crosses below 27 degree, the user will be notified and the user can stop the manufacturing there. Hence, he won't have a huge loss. That's what temperature, pressure, chemical sensors do. And by using by what the MEMS based sensors are, like accelerometer, gyroscope, we can always take those coordinates and all for doing certain data collection. And by actuators, I told you, actuators are what the actuators do are, we will give them an electrical signal, and when that electrical signal comes, the device will do some mechanical output. So that's what basically meant by an actuator. Third is a tracker. Actually, tracker and tracker and sensors are very close, very closely defined things. In sensor, what the sensor do is that it senses the surrounding, senses things from the surrounding, like temperature, pressure, gas. Is a particular gas present in the environment or not? Uh, and would actuate, like from the values of the sensors would actually actuate the actuators. Actuators means it will give a certain command to the actuator to do thing, like do a certain thing. So by tracker, what we mean is that it will only pinpoint a certain location of a certain thing. Like for example, if you have seen the recent Apple event, you would have seen that they have launched an Apple tag thing. So that is a tracker. What it will do, that when we embed the tracker with our keys, car keys, home house keys, what it will do, that it will always ping your location. It will always show that location of that key where it is present currently. So yeah, that's actually meant by tracking. So trackers do just the tracking, just the device location thing only. It won't do any other things like sensors. Okay, so that's why it's very closely defined. Yeah. By trackers, sometimes we can get confused, like is it sensor itself? In some way it can be sensor, but it isn't sensor. Okay, so now let's go to the next slide. Next slide is about the networks and gateway. Networks and gateway is the second layer of the IoT architecture. So what does this networks or the gateway does is that it enables the low power devices. The low power devices means most of the devices that are being used in the IoT, like sensors, actuators, they all are low power devices. We can't handle high power devices. Like we can actuate high power devices using some certain stepping down the power and all we can use, but mostly the devices that are used in IoT are low power devices, for like our phones, the sensors, the actuators can be if you are taking a bulb, actually we integrate the bulb with a relay so that the power can be matched with the power that has been outputted by the microcontroller. So almost all devices in the IoT network is a low power device. So what the network or the gateway does is that it helps the low power devices to enter the big internet world. Okay, so what basically does the network or the gateway does is that it sends the data that has been collected from the sensors. Uh, it sends the data from the sensors through that network to some destination or to the server. So by server, we can use a cloud platform, a private data center that sometimes we call it a local server, and a home network. Home network is also a local server. So what the network does here is that it collects the data from the sensors and sends that data to some other destination, and that destination can be a cloud platform, a local server, a private data center, anything. Okay, so next is the in the network or the gateway, there are some we have to communicate with the server. Okay, so how is the communication done with the server in IoT? So there are basically many protocols that can be used, many devices that can be used for the communication. Okay, so the communication channels that we basically use in IoT is the Wi-Fi, Bluetooth, Zigbee wireless, NFC, Wi-Fi direct, and Bluetooth low energy. Actually, Wi-Fi direct, Bluetooth low energy, or BLE, Wi-Fi direct is a derivative of Wi-Fi, and BLE is a low. It's a Bluetooth itself, but its consumption is very low. So that's why Bluetooth low energy. Okay, so BLE. So these are the channels that are used in IoT for the communication purpose of sending the data from the sensors to the server. Now let's just compare the technology that we are using in IoT for the communication purpose. Actually, we have two things: a local area network and a cellular. So in local area network, Bluetooth, Zigbee, and Wi-Fi. By local area network, you know that it can be just like a small surrounding area. Like if your home, if you're doing the IoT project for your home, then if you're implementing the local area network, then it most probably it will be like 10 kilometers, not 10 kilometers. The range will be very short, like 100-meter or 200-meter for Wi-Fi. Similarly for Bluetooth and Zigbee. So here the data rate is very high. Okay, like from 100 kbps to 100 mbps. Similarly for cellular, you know that the cellular, like the GS. Sometimes what we do is that we connect, like we don't use the Bluetooth or the Wi-Fi modules. What we use is that we use a GSM module. So GSM module actually, what does it does is that in the GSM module we have to insert a SIM, and that SIM actually is used for the communication purpose. So here also the data rate, the communication rate is pretty high. It's from 100 kbps to 100 mbps also. But in local area network, the range is very low. As I have told you, the Wi-Fi range is probably 100 or 200 meters. But in cellular, it doesn't matter actually. Until there is a network, until there isn't a network issue, the cellular will go up. So its range is pretty long. And the battery life, actually cellular's battery life is medium. You have to, by battery life, sometimes we are using these modules on, not on the direct power, like from the sockets and all. We sometimes use it using some batteries and all. So cellular's battery life is pretty low, but at the same time the local area networks battery life is for every other thing it varies. If you are taking a Wi-Fi, it may be long, but when we come to Bluetooth or Zigbee, it may be short battery life. So we can't, it varies for different local area network components. If you are going for the cost, then local area network components are pretty expensive. So is the cellular. So where all do we use these local area networks is that like the smart TV, the Wi-Fi network at home, the Bluetooth, the home automation. Yeah, like local area network can only be implemented if that thing has to automate or do something within a confined region. It does not that process is not uh, that process is not affecting any other thing. Okay, so basically from home automation, let's take the example of home automation. We just have to automate our home. We don't want other people to automate our home, or we don't want to automate other people's home. So like we set up the local area network for just our home. That's what meant by local area network. And cellular, cellular, just like I told you, it can be implemented in CCTV and asset tracking. By asset tracking, I would, for example, if there are some product, a manufactured product that has been transported from Bangalore to Kerala. Okay, so we have to see the location, like where the product have been reached now. So what we do is that we track. That's called asset tracking, and the asset is yours. So what you will do is that you will embed the GSM module with a GPS. So that uh, you can get the location of that asset at all times. So by using GSM, you enables that you can always see that where your package or where that asset has reached. Okay, so that's asset tracking. Now comes the middleware. By middleware, I mean the server, uh, where the IoT data is stored and analyzed, processed. Yeah. So middlewares are the IoT platforms where we can store and analyze our data. So basically, there are many different types of platforms that we can use. The most used in today's life is the cloud platform. Cloud platforms like Google Cloud Platform, Azure, AWS, these all are cloud. What do you mean by cloud? Cloud is an operational system and a hardware computer that is located somewhere in the world, but we have given that but we are given that computers access over the internet. So basically, these servers are located somewhere in the world, and we can use those servers for the storage purpose and analysis purpose by using the internet. Uh, and the next one is a local server. Local server can be that your PC can be the local server. A Raspberry Pi can be a local server also. You just have to input the protocols accordingly. Uh, Today, most of the people prefer to work with the cloud platforms is because that the uh, IoT protocols are predefined there. We just have to go and tell what protocol we have to use, and the whole protocol will be implemented automatically. But when it comes to a local server, we have to define each and every protocol bit by bit. So it's pretty tough and pretty time consuming. That's why most of the people prefer to go with the cloud platforms. Now come the analyze part. So during the analysis, what we are doing is that the data that has been received from the sensors, it it is uh, it is either the data is been either you can visualize the data or build a report of that data or filter the data. Is this data required for us? After that, if we are implementing an ML model or a machine learning model with that uh, IoT project, then what will it do that according to the visualized data or the filtered data, there would be a certain output. If the machine learning algorithm is not present, then after filtering the data or the analysis of the data, the cloud itself will say that uh, we, we, uh, we, uh, we will say to the cloud that if a certain value comes in the cloud, then do this thing. uh, Take the same example of the home automation. when the when the light intensity outside the home reduces a certain value, we tell the cloud that when the sensor data goes below this point, tell the device to turn on the lights. So that's what basically analysis do. So there are different types of analysis. By analysis, we can call it analysis or computing. Most of in today's life, it's mostly called computing. So computing can be done using various methods. First is the cloud computing. When the computing or the analysis is done over a cloud platform, we will call it a cloud computing. Okay, so for those purpose we can use the there are many cloud platforms available today, like uh, in Google Cloud, Azure, AWS. These are paid service. Okay. Other than this, there is ThinkSpeak, Adafruit, Blink also. So these three, the later three that I told you, are free cloud platforms. Blink acts in Adafruit and ThinkSpeak. Uh, we have to tell everything, like we have to automate each and everything according. We have to. It's pretty. You have to know some of basics of the cloud computing for that. But if you are using the Blink application, what they do is that we have to simulate the environment in that application. Accordingly, we will design the whole system virtually in that Blink application. And that Blink application, what will it do? That it will create an application accordingly, and uh, the protocols that is required for that computation will be automatically done by the Blink application itself. So these are the cloud computing platforms. So when the computing is done over a cloud platform, it's basically called a cloud computing. Now comes the fog computing. What we meant by fog computing there, Cisco was the first company that came up with the idea of fog computing. It's nothing. It's just computing it over a local server. Fog computing means computing over a local server is called fog computing. So fog computing is bit tough because, like I told you earlier, it's very time consuming because uh, we have to we have to define each and every protocol in that servers, like when this come, what should it do, and we have to define the communication protocols also. We have to define the data exchange protocols. There are many protocols involved in the IoT, so we have to define each and every protocols in fog computing. Now comes the edge computing, but we have to see that fog computing is faster than cloud computing because it doesn't involve it involves internet if you want, but it cloud is always present in the internet, right? So we have at every time we need to have an internet access, but in fog we don't want the internet access all the time. We just need the wi-fi signals. We can connect to the local server accordingly if the wi-fi is working. We don't need that internet or the data for communication, but in cloud we need that data for communication. So fog computing is faster than cloud computing. Next comes the edge computing. Edge computing and fog computing are pretty similar. So in both fog computing and edge computing, what it's meant by uh, the analysis or the computing part is done at the edge of the network. By edge of the network, it means that at the device end itself. Let me see. For example, uh, take home automation. Okay, so when the sensor data is being taken from the sensor, the analysis or the computing is done at the sensor end only. When the data from the sensor come to the microcontroller, actually the microcontroller is the thing that sends the data to the cloud. So rather than sending the data to the cloud for the analysis, what does happen here is that at the edge, when the data comes to the microcontroller, it analyzes itself at there only. So that's the edge. So the computing is done at the edge itself. So that's what's meant by edge computing. Here there is a actually edge computing is a combination of fog computing and cloud computing. Fog computing is totally done at the local level, local server level. But in edge computing, the analysis is done on the local server, and the key data, like not all of the data is sent to the cloud, but the key data are sent to the cloud for the storage purpose. So that's what it is meant by cloud edge computing. Next is the act stage, or the final the act stage. So during that act stage, what happens is that the cloud computing, the device takes action based on the information and the data that has been sent from the server. So for example, like I told you before, in the medicine manufacturing plant, when a certain temperature when the temperature goes below a certain temperature, the user will be notified from the cloud that the temperature has been dropped down. So that is an action done by the cloud. Like the temperature has been dropped below 27 degree. Then the user is being notified like the temperature is 26.9 degree. Now you have to shut down the device. So that is an action. Similarly, if you take an home automation, when the sensor, the photoresistive sensor value drops below a certain value, the lights are turned on. So that is action. So how does the action takes place? The server communicates with the output device. The server tells the microcontroller to do this thing, and microcontroller execute that command accordingly. So actually actions can be like communicating with machine to machine, sending a notification, or talk to another machine. Like if we are talking about a cloud platform, then the cloud platform itself is a machine. Then that cloud is talking with our machine. If you're taking the home automation, then it's the bulb. Then the cloud is talking with the bulb. Similarly, it's same, the communication with another machine. Now the application. This is a very important layer in the IoT architecture, because in this layer helps the machine and humans to interact with each other. By application, we can use a website or an Android or an iOS application. What the application basically do is that it will show what is happening right now at the cloud or at the server. Take the example of home automation. If you are going outside your home and you are in a hurry, you lock the door, you get into your car and just drive you drive away. So after some times, you look at your phone, you open that application that is been linked with your home automation system. Then when you open that application will show that the fan in room number 2 is turned on. So you would have probably forgotten to turn off the fan due to the hurry. So what you can do is that you can turn off the fan using that application. You just what we have to do there is that we have to give a button in the application to turn on and turn off. So if we saw an appliance that it has been turned off even after we have left the home, then we can turn off that device using that off button. When we press that off button, actually what happens there is that a message goes to the cloud that the user has requested to turn off that particular device. So cloud interprets the device and from that message, the cloud execute the command that has been sent by the user. So accordingly, the cloud will send a command to the device, to the output device, and the output device will be turned off. So that's why an application layer is always important, because there can be sometimes where failure can happen. So an application layer is somewhat for a safety. Just a minute. So basically, the IoT architecture has been covered. Now let's see some IoT applications where the IoT can be applied. IoT can be applied in the environment for environmental monitoring. Like for a city like Delhi, pollution is a very serious issue. For out of 12 months, I think around 8 to 10 months they have pollution. So for that, we can implement IoT. Like we can notify the people that the pollution is going up and up. So we can alert them, stay in the home or wear mask, like that. Now, for safety and security, we can install CCTVs over a cloud platform, and we can access anything can be accessed. The things that can be accessed over internet, it's an IoT device. Okay, so in agriculture also, nowadays in agriculture what is happening is like that we embed some sensors that actually measures the humidity present in the soil, the air present in the soil. By using these values, we can actually uh, plan our plan our season accordingly for the agriculture purpose. So similarly in healthcare, you can see a person's if the healthcare system is IoT implemented, then we can see that person's ECG. Uh, Take an example of a ventilator, and that ventilator is connected to a cloud, and the doctor is staying at his home, and the doctor want to see the patient's status right now. So what the doctor will do is that he will log into the cloud platform, and he will select the patient, and the patient details will come there, like what his current heartbeat is, what's the ECG, what's the pulse rate, what's the oxygen rate. Every information will be provided in the cloud platform. So that's what it's meant by healthcare. So there are many other applications also, like smart utilities. In smart utility, it come smart parking, smart electricity meters, water meters, etc. And asset tracking, as I have told you earlier, asset tracking is nothing but it's actually it is done when logistics is happening. If a product is coming from certain place to certain place, then we have to locate that where the product have been reached till now. So asset tracking help us to track our asset, like where the asset is right now. Similarly, facility management. Facility management means the smart cities, smart buildings that are going to come now. They are a facility. So by management, we can see the power consumption of the city. We can see the traffic. If it is a smart city, we can see the traffic in that city. All those things which is present in the which can be accessed through internet. That's an application. These are the applications of IoT. So let's see some more applications deeply. So this is an illegal parking scenario. What happens here that some person has parked the vehicle at a wrong place. Okay. So what happens here that there will be certain sensor there, and that sensor sense that something has been parked here without a consent. Okay, so then what it will do that it will send an notification to the cloud that something has been parked here, that's illegally parked. So what does the cloud does is that it will inform the police that this vehicle, a certain vehicle is parked illegally at this location. So police can come to that location and see that is there a vehicle like that present or not. These type of illegal parking scenario projects can be very helpful in very congested areas like in Delhi, in Ernakulam, where parking is a very big issue. Okay, now is an organized parking scenario. What happens here is that uh, it's actually a parking lot, and when we enter the parking lot, we don't know where that where will be where there will be space to park our vehicle. So what will happen here is that we can access the application that has been provided by that parking lot company or the park that organizer. We can access that application and we can see where there is there a space in this floor or not, or in this area. So accordingly we can go and park. We don't have to look like is there a space here or is there a space there. So we can actually save a time save time rather by not wasting our time looking for spaces. Next is the smart waste management. By smart waste management, what we meant is that take a dustbin, a municipal dustbin. Okay, so when the municipal dustbin fills up, there will be a sensor implanted in it, and that sensor will what the sensor will do that when that waste crosses the particular threshold, that uh, sensor notifies the cloud that the dustbin has been full. Accordingly, the cloud will notify the municipal department that this dustbin at this locality has been full, and they should uh, clean it up or take the waste from the bin. So that's a smart waste management. Now, organized water meters. By organized water meters, what I meant is that nowadays in Delhi and all, we have water meters, and the person from the water authority comes and uh, look into the meter and take the reading from the meter. Rather than doing that, what we can implement here is that we can digitize that meter and take the value from that meter and upload it to the cloud, and from the cloud the water authority can access it, and accordingly they can bill it. So that's what organized water meters are. Similarly, energy meters, the electricity meters can also be automated. So let's now see what does an IoT project needs. First is the devices that can communicate, like sensors, actuators, cloud platforms. So these are all devices. Cloud platform is also a device or a machine, or a local server is a device. Your PC is a device. So that we have to select the devices accordingly so that they can communicate with each other. So while selecting sensors also, we can't go and select all sensors for an IoT platform. There are certain criteria for selecting sensors, like is it compatible for IoT? We have to see that bit rate, is that and the error rate. Like if we are selecting a certain sensor, we have to see that is the data given by that sensor accurate or not. If it's giving you a very high error, then we can't use that sensor for this purpose, because IoT projects have to be done very accurately. Otherwise, then automation or the whatever the project is, if the data is inaccurate, the project will fail. Second is an application for the human and machine to interact. It's very important because we don't know when something goes wrong. So we have to have an application. Third is the user, we. If we don't want a project in IoT, why should we go for it? If if there is a necessity for a person to go and automatism, then only will he do it. If he doesn't want it, he won't. So that's basically three things required: the devices that can communicate, applications, and users. Okay, so the devices that can communicate are the microcontroller. Microcontroller, as I told you, it's the brain of the system. What it's basically do is it reads the input from the sensors and drives the output accordingly. Okay, so the brain, what does the brain does is it inputs the data from the sensors and communicate it to the cloud, and from the cloud sends a command to the microcontroller. The microcontroller receives a command and drives the output accordingly. Next is the network interfaces. By network interfaces, like gateways, I told you Wi-Fi, Zigbee, Bluetooth. These are the network interfaces that are. These are also the devices. Like for Bluetooth and Wi-Fi, we need modules so that we can connect to the internet. So network interfaces, and finally power source. Without power source, nothing will be working. Okay. So what do we currently have? We just have in IoT we currently have, like we have a device, it's connected to a Wi-Fi or a Bluetooth or a cellular GSM module. It sends the data over to the cloud, and that cloud notifies the user, and the user accordingly give an input to from the application. Like I told you before, in the home automation situation, when the user see that the light or a fan is turned on, so what happens there is that the fan sends uh, uh, sends the data like it's turned on, like it's high. Basically what we do is there, the fan or the light is high, then we send the data like the fan is high to the cloud, and the cloud sees that it's high, then it will go to the application, uh, and the status of that component uh, will be shown like it's high or it's on. So when the user sees that, the user return touch user turn off the uses the turn off button to turn off the fan. So what happens when he press the turn off button? The message uh, the message is sent to the cloud that user has requested to turn off the fan. Then accordingly the cloud interprets the message and gives command to the Wi-Fi or the microcontroller to do that. The user has requested to turn off the fan, and then the microcontroller drives the output accordingly. So what we need here is that, like I have told you, we have to most of the IoT related projects are basically on the automation. Like we have to minimize the human interactions. Okay, so we have to automate maximum. So like I have told you before, in the home automation scenario, when the lights goes down, then the lights should be turned on in the house. And similarly, like if the weather is bad, okay, then we have to get a text message like, okay, today's message weather is bad. These are all examples that we need. Some of them are implemented right now, some of them are not. Like for example, take an home automation system that has been implemented using a machine learning. So in machine learning, we can study the human behavior, like when is he coming home, what does he do after getting back to home, and all. We can study the whole behavior of the human for some time, and after that we can use that machine learning algorithm to run the cloud. Okay, like if it's 8 o'clock, turn on the geyser or turn on the AC. Okay, like that. So actually, according to this graph, in 2020, in 2021, it's 35.82 billion devices that are connected over internet, and it is expected to go to 75.44 billion in 2025, or more than double. Okay, so that's how faster is IoT growing these days. So IoT is growing very much fastly, and almost every person who is going to who thinks that he can have a career in IoT will definitely have a good career in IoT. So what are the benefits of IoT? It can track real-time behavior. Okay, tracking behavior for like human behavior. Like I told you, if we are implementing a machine learning, then we can track human behavior in real time. Then enhance situational awareness. Like in this home automation scenario itself, when you leave the home, you can actually see that if you can actually see that is there any theft going on or not. You can implement certain those like projects in your home also, like anti-theft projects. If a person comes through your door when you are not there, it can alert you and you can alert the police. Okay, so like enhance situational awareness. Then sensor driven decision analytics, like I told you, when take a plant monitoring system. If a plant does not require more sunlight, so what we can do is like we can plant an photoresistor there, and if the sunlight is very high, then what we can do is like tell the microcontroller uh, tell the microcontroller that the threshold has been crossed, and a shade can be provided to the plant. So the plant has been saved from uh, over sunlight. Now, next is optimize resource consumption. By resource consumption, we mean if we are doing the IoT project very balancedly, then the power consumption, energy consumption will be very low. So, power consumption and energy can also be benefited from these projects, but we have to design the architecture very carefully for that. Then instantaneous control and response in a complex autonomous system. Like I told you about the home automation system, you can instantly control the status of your lights and fans even if you are not present in your homes. Okay. Now, what are the challenges faced by IoT? First is the security. As everything is being connected to the internet, hackers can hack. There have been situations where hackers have hacked into your home, and actually there is a concept called smart door where you have to just use your fingerprints or some password to open that door. Hackers have hacked that thing. They have used this thing for uh, robbing and all. So security is a very vital thing in IoT. So for security reasons and all, in cloud platforms, sometimes blockchain is implemented. Blockchain is very secure nowadays. So blockchain is also applied for security purpose. Now comes the compatibility. As I have told you, not all sensors can work in IoT platform, IoT conditions or IoT environment. So compatibility is a very big challenge. Now comes the brownfield deployment. What do we mean by brownfield? Brownfield deployment is that we have to deploy a new component to an existing environment. For example, just take take a home automation example. We have to replace a bulb that is present in the home automation system and replace it with a new. Sometimes the bulb won't work because it isn't compatible. So brownfield deployment means integrating some new components into an existing system. Next is power. As I have told you, if you don't design a IoT architecture carefully, power surge will go. The power consumption will go very high. And finally, connectivity. Internet is all about connectivity. If there isn't connectivity to the internet, if the devices can't be connected to the internet, then there won't be any control. There won't be any automation. You can't control your things that is present in your homes. In case of the home automation, or in case of the factory, in the medicine manufacturing factory, you can't control those machines if the connectivity with those machines is not there. So connectivity is also very big challenge in IoT. So what the future shall bring, like I have told you, more and more autonomous things will come. More and more this IoT will be implemented more with AI and ML. This IoT with AI and ML will have a big scope in the coming years, and there are still projects that are going like in the research part, like can we do this in using IoT and ML. Home automation is done using IoT and ML. Certain industries are operated like that. So we have to there are different branches in IoT also, like the security. I have told you security is a very important thing in IoT. So security have a different branch in IoT. So there will be some development, like more and more secure communication can be provided. The data can be more securely stored. It will be encrypted differently. So security is there. Then for the analysis part, some new algorithms, machine learning algorithms will come that will be more accurate than the previous one. So that's how the future behold for IoT. So yeah. So guys, you can connect with me in LinkedIn. Okay. So if you guys have any doubts, you can go. Other yeah.
Okay, so now it's time for the interesting session, the question and answering session. So those who have any queries, you can put it in the chat box.
How can we protect our devices remotely under conditions such as lightning, fire, etc., when we are not aware of the weather changes? Okay, this is actually an automation. Like the user doesn't know that there is the weather is going to be worse or not. The user doesn't know about it, but the system should. Otherwise, we just can protect it locally. Like we have to do the wirings and all accordingly. But if the user doesn't know and the system knows, then what the system will do is that it will cut off the power. Like it will turn the MCB down accordingly. If there is a lightning going on outside, then the device can like turn off the MCB. By doing so, it can protect the um, like components from lightning and all. Yeah, I hope that clears your question. Is IoT one of the best path that an EC engineering student can follow? See, dude, IoT is basically a CS department thing. Okay, but if you have an interest, really, like IoT is all about embedded systems. Okay, there comes the software part also, there comes a hardware part also. So you have to balance all of these things accordingly. If you just can't look into one thing only, you can't just look into hardware part, you also have to look into the software part. So you should know a basic knowledge. Like you have to start from the basics, and you should go and expertise in some field in IoT, but you should know how the whole IoT systems work. I think EC students can do well, because in EC students have like hardware knowledge also, and they also have the software knowledge. They know the basics of the programmings and all. So I think they can go ahead with the IoT path, but you have to see that IoT is not an easy thing. When you start doing projects, when you start learning about IoT, you will see that it's more deep and deep. You have to go and research more and more every day. There will be something new every day. So you have to pace up yourself. You have to learn. You have to be ready to learn new things every day. Okay. Yeah. Increased IoT usage might cause increased security concern and privacy invasion. Yeah, that's what it's meant by the security issues. Hackers can I have read a technical paper. In that technical paper, it is said that if the if the smart water or the smart electric meter thing is implemented in an IoT situation, then if a hacker hacks into the system, he can see that when is the user not at home, or when does a user leaves home and comes back, and there are if the IoT usage increases, there will come the privacy issues will be there. But at first we implement the project and we start to debug it accordingly. So we will see that when the issues come up, we will come with some solutions accordingly. So bit by bit, there will be solutions also. So definitely there will be privacy issues, but yeah, it won't be like forever. The privacy issues won't. The privacy issue won't last forever. So the IoT engineers will solve the issues accordingly. Which computer language mostly? So there is no particular language. It's basically if you are just in the microcontroller itself, we can use Python and embedded C. If you are using an Arduino, you have to use embedded C. If you are using Raspberry Pi, you have to use Python. So accordingly, you have to know Python or C for, like, if you are working with Arduino, C is enough, and you have to see like how the cloud computing goes. If a cloud computing requires some other language, you have to go and learn that particular language also for that cloud computing purpose. Otherwise, yeah, whatever language you prefer, you can like do Python or embedded C is good. I think go with Python because Raspberry Pi nowadays is Raspberry Pi is like a mini computer, so it can also work as a server itself. So have go and study Python.
So I hope that is the questionnaire session.
Okay.
Now,
Thank you everyone for listening so patiently. Thanks everyone. Okay, so if you have any doubts further, just ping me in LinkedIn. I will be there. Okay.
okay, you can definitely contact Mr. Ashwin Shaji for your further queries. Now, the most important thing, the feedback forms will be putting in the chat box. So you can fill the feedback forms as soon as possible. We'll be closing the feedback forms within 5 minutes. So you can go grab your certificates. Do fill your feedback forms.